Okay, guys, so I think we can go ahead and start. So good afternoon, everybody. Happy Thursday. Welcome to our online event called A Visual Testing Revolution. So before we get started with the content today, I'd like to always go over a few notes and how to participate on today's session. So as usual, duration of this session will be around 1 hour. And the speaker will be presenting around 40 to 45 minutes, followed by a Q&A session, 15 to 20 minutes. So if you have a questions to our speaker, we ask you to please address it through the chat anytime during the presentation, or wait till the Q&A session at the end of the presentations, and our speaker will try to answer to as many questions he can during this event. So also, I'd like to remind everyone that today's presentation will be recorded, and we will be posting all the recordings to our YouTube channel. And for those who couldn't join the call, or anyone who wants to rewatch the session and make notes from the presentation, you can do it so in our YouTube channel. So now, without any further ado, I'd like to introduce our speaker for this session. Andrew Knight joining us today from North Carolina. Andrew Knight, also known as Pandy, and he's Automation Panda. He's a software quality champion who loves to help people build better quality software. In the past, he's built large-scale test automation projects that run continuously and reliably. Currently, as a developer advocate at Applitools, the Panda helps folks make their apps visually perfect. He serves as the director of Test Automation University, which offers a multitude of free courses on software testing from the world's leading instructors. On the side, he's writing a book on software testing with a Manning publication. So really, to be honest, really excited to have Andrew with us here. And without any further ado, Andrew, why don't you go ahead and take it from here?
Thank you so much for that awesome introduction. And hello, everyone. I'm not sure what more I can or should say about myself. So let me share my screen here. Please Zoom work. Okay, share. All right, can everyone see my screen? Yes? No?
Yes.
Okay, great. Awesome. So thank you all for attending my talk today. As you've all heard, my name is Pandy Knight, and I'm the Automation Panda. My background, historically, for about a decade, I've been a software engineer in test, building high-scale solutions for testing problems. But for the past almost a year now, I have been the developer advocate at Applitools. At Applitools, being developer advocate, my job is to basically advocate for you as developers and testers, help you get unstuck with testing problems, help you learn about good testing practices and cool tools and stuff and how to use them right, and specifically around visual testing with what Applitools has to offer. Another cool thing I do at Applitools, I am the director of Test Automation University. I'm hoping many of y'all have heard of TAU. If not, TAU is one of the best platforms for learning about testing and automation and software quality online. We have courses from literally the world's best instructors, and it's all available for free. I even have a few courses up on TAU that I developed before I worked at Applitools. I'm even wearing the TAU t-shirt right now. So if you have taken any TAU courses, drop them in the chat. Let me know. I'd love to see and hear what you've taken. So today I am going to be talking about testing. Surprise! Yeah, who would have thought? But in particular, I'll be talking about visual testing. Visual testing techniques are an incredible way to maximize the value of your functional tests. Instead of coding a bunch of assertions based on text or attributes, visual testing captures a full snapshot of a page and looks for visual differences over time. My goal today is to help y'all open your eyes to see how visual testing can revolutionize how you approach software quality. In my opinion, this isn't just like another nice to have kind of thing. It's not a feature that's only for those on the bleeding edge of technology. Visual testing is a tried and true technique that anyone can use, and it makes testing a lot easier. So I want you to see things in hopefully new ways. We all know that there are several different kinds of testing. You name it, there's a type of testing for it. Unit testing, integration testing, end-to-end testing, functional, performance, testing web UI, mobile, REST API, acceptance test-driven development, behavior-driven development. Oh my gosh, like we could play buzzword bingo. There's so many different kinds of testing, so many different names. But what is testing? Just at its most basic form. In simplest terms, testing is interaction plus verification. That's it. You do something and you make sure it works. Whatever kind of testing terminology you have, every kind of testing reduces to this formula. Manual testing will accomplish this with direct human interaction. Somebody needs to bang on a keyboard, click a mouse, hit around tabs to drive the test. Automation, on the other hand, drives interactions and verifications with a script. We like to think that automation is really great because if we think it doesn't need human intervention, but we all know that's not true. Humans still need to write the tests, develop the scripts, and fix them when they break. It's paradoxically, automation is not fully autonomous. But visual testing can help change that a little bit. Although humans will still need to figure out interactions, visual testing techniques make verifications autonomous. Teams take snapshots of their views and look for changes over time. They catch more kinds of problems while ironically simplifying test code. A tester doesn't need to think critically about what specific elements to check on a page. Snapshots capture everything. Unfortunately, many folks seem to have the impression that visual testing is a quote-unquote advanced technique, that it requires a high level of testing maturity to be valuable, or folks need a certain maturity of skill level. And I want to say that's not really the case at all. In fact, I want to flip that script entirely. Visual test automation is easier than quote-unquote traditional test automation. This isn't something just for like FANG companies to do. It isn't out of reach, even if you're just starting your testing and automation journey. Visual testing makes functional testing easier and stronger. It's something teams should do first before attempting to automate longer, more complicated tests with traditional ways. Big claims, right? In this talk, I want to dig into what all that means. So what we're going to do is we're going to automate a web test together in Java with Selenium WebDriver using more traditional interactions and verifications. And then we're going to supercharge that test with visual testing techniques using Applitools as a platform. So to get started, we first need a web application to test. Now, we could test an application of any size, but I'm going to choose a small one for the sake of our demo today. Here is Applitools demo site. It mimics a banking application. You can go to demo.applitools.com and you can see you can interact with this page yourself. What I'm showing is the login page. It has a main icon, has a username, has password fields, and it has a sign-in button. Now, since this is a demo site, you can actually enter in any username or password that you want. Cool, right? But after clicking the sign-in button, you'll end up on the main page. And there's a lot of stuff on this main page. You can see it's got the top bar with like the name of the application, the search field, you've got icons for your account, you've got financial data, you've got a sidebar on the left there that shows different account types. You know, it's got a lot going on. We could write a basic login test for this application in 4 steps. Step 1, load the login page. Step 2, verify that all the elements appeared correctly. Step 3, perform login. And finally, step 4, verify that that main page loads correctly. This would be happy path, probably something like a smoke test, nothing fancy here. We could automate more interesting tests for this, but right now I just want to keep things, just basic. Really, the trickiest part of automating this test would be deciding what elements to check when the pages load. So we're going to automate this test in Java using Selenium WebDriver. Now, technically, we could write it using any popular language or tool. Personally, right now, I really like Python and Playwright. That's kind of my jam. I'm actually a Playwright ambassador. Wow, we just launched a program. It's cool stuff. Playwright, if you haven't heard, it's a new end-to-end web testing tool from Microsoft. And it's a lot like Cypress in some ways, and then it has a really nice, concise API. But what I like about Playwright is that it has bindings in multiple languages, like Java, JavaScript, C#, and Python. And it's faster. It is blazingly fast, which is really, really cool. But still, today, 2022, Java is still like one of the most popular languages for test automation. Selenium WebDriver remains the most popular browser automation tool out there. We could use other languages. We could use other tools like even Cypress or Playwright. But I'm just going to keep to something that's popular with what a lot of people are familiar with. So in Java specifically, we can write a JUnit test class named login test, which I've shown here. And we can create a test case method named login. And here, every one of those 4 steps I have as a call to a helper method. So let's look into those. First method, load login page, loads the demo app's login page in the browser. If you're familiar with WebDriver API, it's just driver.get this page. The second method, verify login page, verifies the appearance of 5 critical elements on the page. Things like the logo, the username field, password field, sign-in button, and that remember me checkbox. Here I have a helper method called wait for appearance that is doing an explicit wait to make sure that these elements actually loaded in the DOM of the page, that they actually exist. It's not checking where they exist or even like what their contents are, like their text or anything. It's just making sure, did I get these fields? And I'm using those locators, CSS selectors or IDs. Note, I'm not going to be using page object model or screen player or anything here. I just want to keep it just plain old Selenium WebDriver. So that wasn't too bad. Let's see the third method. Third method actually performs login. As I said before, you can use any username and password. So I just put in Andy and I heart pandas, right? It'll go through. So we type in username, type in password, hit click, and then it should perform login. The fourth method for verifying that the main page loads is quite a doozy here. So remember all the things on that page. That means that we're going to need several assertions to verify. So at the top here, I have a bunch of assertions using that wait for appearance method, just checking to make sure certain elements appeared, like some of the stuff on the main menu, some of the stuff on the sidebar. Other checks need to perform some sort of text matching. For example, to check the banner at the top of the page that says your nearest branch closes in however many minutes, we need to find the elements, get its text, and then perform a regular expression match. So again, it's still an assertion, it's just a little more complex. Then, if we want to do things like checking the account types in the sidebar or checking some of the status fields in that financials table, that requires even more. We're going to have to scrape the page for those lists of elements, map their text values from the element objects, and then do some data transformation on the results so that we can perform those assertions. So these 2 sections here that I've highlighted, they're kind of similar and they're doing those patterns. One of them is just doing a straight list equal, the other is checking for a contains operation. What's a shame though is that despite all this heavy lifting, the page still doesn't check everything on the main page. Things like dates, amounts, descriptions are all ignored. And when I implemented this test, I did that as a risk-based trade-off. Just to get this code here probably took me about 20 minutes, half an hour of trying things on the page, inspecting elements, coming up with locators, running it, finding out my locators weren't good, trying it again, right? But I also had to decide what to check and what not to check. And it is that risk-based trade-off. We could add more assertions, but that would lengthen this method even further, right? So there's even more it's trying to cover. There's more code I have to develop and maintain, and it becomes a bit even more complex to try to keep in your head when you're trying to understand what the test does. But the trade-off is the fewer assertions that you make, the weaker the test case is, right? I'm not checking something like the actual numbers in the table. What if the dollar amounts go haywire? This test isn't going to capture that. Trade-off. Also, another trade-off is, well, if you do want more assertions on this page, you're going to have to maintain that in the future, which means changes to the page under test are more likely to cause breakages in your test automation. Automation is inherently brittle. It relies on the product under test. So all that to say, you do a lot of work for an okay kind of verification, and you just have to recognize that your test can't cover everything, which is not so nice. So if we run this against our web application, the script that we wrote in Java with Selenium should pass without a problem. What if the page changes, though? So here's a different version of the same page. Some slight visual differences. What's going on here? What do we see is different? You can shout it out. You can type it in the chat. I'll go back and forth a few times. So yeah, there we go. So the login icon, first and foremost, absolutely. Oops. Yep, that image looks to be broken. Are there any other changes that we see? What about that sign in button? So here's the original page. It's a blue button that says sign in. Color. Yep, so it went from blue to black, but the words also changed. Now it says login, right? So what would happen if we were to run our tests with this visual difference? So it would be really helpful to kind of compare these side by side, right? As we can see, yeah, the logos are different, sign-in buttons are different. Nailed it. Now, personally, while I'd probably ask my developers about the sign-in button, like, hey, was that intentional? I would categorically consider that icon difference a bug. Why? Because it's a broken image link. Like that, something clearly went wrong here. However, with our script that we automated, as long as the page structure doesn't change, the login test we wrote would still pass, right? We can see this page is broken, but you could run it against this page and it would still be fine. Why? Because it's just checking for the existence of elements. It's not checking for their visual side. It's not checking for their text or their color or anything like that. So with those traditional kinds of assertions that we just saw together in the Java code, we wouldn't be able to detect these visual bugs. And that is an enormous risk for testing any sort of UI-based application. So revisiting our locators, we can see, these locators are hinging only on very basic attributes of those elements on the page. They're just saying, oh, if you have a CSS selector that has this tag in this class, or if you have any element with the ID of username, if those appear, you're good to go, right? So it could be completely swizzled and it could be wrong. I mean, we could even have a page that looks like this. What I did is I took that login page and I basically stripped off all of the CSS, basically all of the styling. Structurally, it's the same page. And yes, if I were to run the script, if I were to run the script against this page, guess what? The test would pass on this, even though this is very, very clearly broken. So these are huge test gaps, huge test gaps. And really trying to add more traditional assertions probably wouldn't catch these kinds of problems either. Oops. So what if we could visually inspect the page. You know, what if we had a tool to do that? Hold on one second. If we could visually inspect side by side, what we could do is we could take a baseline snapshot of the application or the page in the application that we call good as like a starting point. And then every time we run our tests, we take a new checkpoint snapshot. And then within this tool, we could compare these things side by side and try and easily detect any changes and decide if they're good or bad. In a nutshell, this is what we call visual testing. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. I mean, visual testing is not necessarily something that's new. I mean, you could argue that with manual and exploratory testing of UI-based applications, we've been doing visual testing as testers, developers, and as a community and industry since the first screens came about. It is arguably the most, or one of the simpler kinds of manual testing. You try something and you look at it and you think, oh, is this what it should be? What I'm talking about though is let's take that and let's make that aspect of testing, the visual aspect of testing, automated so we can really start to scale this up. And disclaimer, that's what Applitools does. So one visual snapshot of a page captures everything on the page. As a tester, you don't need to explicitly state what to check. That snapshot implicitly covers everything: layout, color, size, shape, styling. And that is a huge advantage over those traditional assertions that we saw before. You know, like I said, this is conceptually not new. It's the fact that we have tools to automate it now that is more recent within our industry. All right, what we want to do is we want to take those human sensibilities of detecting visual differences and power that with a machine to be able to run this much faster and much more frequently. Unfortunately, human reviews just don't scale well. I mean, it's very important to have that human touch, to have someone ultimately be an inspector of that. But when we look at modern web app development, or just modern app development in general, web, mobile, desktop, you name it, modern apps have several screens we're checking. And we live in a world of continuous integration and continuous delivery, where systems are deploying changes multiple times a day. Humans can't keep up with that pace. Also, humans make mistakes. They get tired. They miss things. There's a limited amount of time. I personally, this reminds me of the legend of John Henry. Has anyone heard of the legend of John Henry? Some folks might. It's American folklore. So the tale of John Henry goes back in the late 1800s, I think. John Henry was a railroad worker. He was working on the Great Bend Tunnel along the C&O Railway in West Virginia, though some variants of the folklore legend have him in different parts of the country. And he was a worker. You can see the picture here. He's got the big old hammer. He's hammering in the stakes and drilling through the mountain bedrock there. But the story goes, the railroad company that he worked for bought a steam-powered drill, and they wanted to replace their human labor. And so John Henry competed against it head-to-head. He had a 10-pound hammer in each hand, and he's drilling through the rock while his steam engine is drilling through the rock as well. And ultimately, during this contest, the legend goes that John Henry drilled deeper and farther than the steam engine could before the steam engine stopped. But sadly, at the end of the challenge, he died from exhaustion because it was too much work. And so this legend serves as a parable that even the strongest, sharpest human is inevitably no match for a machine. We see this with trying to scale our testing. We can see it in all other kinds of industries too. To be relevant in a modern software shop, we really need our visual testing to be automated, but it's easier said than done. Programming a tool to capture snapshots and then perform pixel-to-pixel comparisons isn't too difficult. It's just a little bit of programming. But what is difficult is determining if those changes matter. A good visual testing tool should ignore changes that don't matter. Things like you had a small 2-pixel padding shift. Like that ultimately doesn't matter. What matters is like your button's missing, right? We want to be able to drill into what matters from what human eyes would be able to detect and worry less about small shifts of things. Otherwise, your automated visual testing would just generate a lot of noise. And it would nullify the benefit of any automated testing you've got. So to illustrate this point, take a look at these 2 pictures here. It's like when we were kids and we had those magazines where it's like you had the coloring book section and the like little maze you had to circle through, and there was also the spot the difference pictures. So in this cute underwater scene, how many differences can you spot? Give it a few seconds here. Let everybody look. And feel free, drop it in the chat how many differences you see, or shout it out on the Zoom call, whichever is easier. Do 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 do. Do 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 boo do 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 boop do 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 do. All right, so Prakash is saying there's 6. Elena's saying there's 7. Someone's saying the squid's mouth. Yeah, okay, giving away the answers here. That's cool. So are we feeling good about 7? We think there's more. We think there's less. All right, who's ready for the big reveal? Uh-oh. What happened here? Why is everything highlighted? Herein is the example of why pixel-to-pixel comparison is no good. What I did in these images, when I captured these screenshots, I actually shifted one of them a few pixels to the side. So you can see like the white bars on the side line up, but everything else in the picture is seen as different because with a straight pixel-to-pixel comparison, things shifted. And so pixels were not aligned, and therefore it spotted everything as a difference. As humans, we can clearly see that these images are very similar, but the pixel-to-pixel comparison didn't reveal that. And so basically, if this were my automated visual diff, this would be useless to me. This is where an AI-based approach really helps with visual testing. So visual AI can detect those meaningful differences that might be a little bit off or a little bit skewed and drill into them rather than just giving everything as noise. So what I did with these pictures here, I actually ran this through Applitools with what's called a strict comparison. And so we can see it pinpointed exactly what the differences were. So, I mean, one of them is the squid's mouth. Yeah, we got that one. But there are a total of 10 differences here. For example, top right corner, fish versus starfish, the end of the octopus's tentacle, one of the fish's fins, some of the bubbles, whether fish is behind or in front of some of the seaweed there. There's a fish that's completely missing in one of them, or like the crab smiling. So it's really awesome that it could, boom, just pinpoint right for us. And furthermore, when I ran this through the visual AI checker, it took like a split second to identify these. It was like, boom, almost instantaneous. Whereas we as a group of 15, 16 people, however many are here on the call, we collectively looked at this for like a minute and we only came up with, I think the highest number was 7. So what we see is that the visual AI was faster and sharper than us as a team of manual testers, quote unquote. And so that's another major advantage of good automated visual testing. Visual AI focuses on the meaningful changes to avoid noise. Visual test results shouldn't waste testers' time over things like the small pixel shifts or a little bit of skew, or like if it's on a different platform and the viewport was a little off, stuff like that. That just causes noise. Humans wouldn't really even notice it. Good visual testing tools should highlight what matters. Missing elements, different colors, skewed layouts, that kind of stuff. And so I would say, you know, visual AI is really a differentiator when you go to choose, you know, what visual tools you should take, because there are a lot of them that it's a very simple pixel to pixel, and that's all they do. So what I'd like to do next is, now that we have seen what visual testing can do, I'd like to update that traditional functional test we wrote in Java with visual testing, and specifically using Applitools as our visual testing tool. To do this, you will need to create an Applitools account. Anyone can create one. Go to applitools.com/register. I'm showing the page here. You can use your GitHub email, or so you can use your GitHub account or an email address. It's free. You don't need to enter a credit card or anything. It's just, you'll get a few free sessions per month that you get to use on our free tier. When you sign up for an account, you'll also get what's called an API key. Your API key is essentially your automation password that you need to set as an environment variable for testing, and your automation will read that in. And when it posts the visual snapshots it captures to the Applitools cloud to do the visual diff, that API key is what links it to your account. So it's your test results. So next, after we have our Applitools account, what you'll need to do is you'll need to add the Applitools Eyes SDK to your project. For Java, it's just a Maven package. In all the other languages and tools and stuff, we've got SDKs for everything you can imagine. So if you're doing Python Playwright, you know, boom. If you're doing TypeScript Cypress, boom. If you're doing Protractor, Puppeteer, Capybara, Appium, you know, XCUI, if you're doing like iOS stuff, right? We've got SDKs for lots of stuff. Here with since we're doing Java and Selenium, we need the Selenium Java 3 package from Maven. We'll add that to our POM file. Then we need to start setting up visual testing objects, and we'll do that in a test setup method. Now, we're still going to use the Selenium WebDriver objects. That doesn't change. But we're going to need some other stuff too. We're going to need what's called a visual grid runner to upload snapshots to Applitools Ultrafast Grid, which will be rendering screenshots for us in the cloud. You're not going to be doing visual comparisons locally. You'll upload that to the Applitools cloud, and it'll do it there. We also need an object called Eyes that will take visual snapshots during test execution. As part of our configuration, we need to set that API key. I recommend setting that as an environment variable. And we need to set things like the batch name, you know, for the collection of tests we're about to take. And then we also need to specify all the different browser configurations we want to test, right? You know, we'll be running our test once on our local machine, but with the Ultrafast Grid, what we can do is we can specify, do you want to render that snapshot on Chrome or Firefox? And we'll talk about that a little bit more later. So getting down to the steps of the test case. The actual step 1 through 4 are going to be the same, but the before and after our test case, we need to open our eyes. That's that eyes.open call. And we need to, at the end of the test, close our eyes. That's what tells Applitools, hey, here's the test case for which we are going to be capturing visual snapshots. We'll also pop in the application name as well as the test case name so that when results are uploaded to the Applitools dashboard, you'll be able to filter everything. So the steps for the interactions are going to be the same. So the login, or loading the login page and performing login, identical to what we had before. What will change are those verification methods. So here's the verify login page method. Before we had 5 traditional assertions, just checking page or element appearance on the page. But with visual testing, that reduces to 1 line. Eyes.check, the full target window, and we're going to call this snapshot the login page. 5 lines reduced to 1. And because I'm capturing the visuals of the whole page, it's actually a much more comprehensive and robust assertion that it's going to perform, right? Before, if I wanted to check things like color, layout, size, all that stuff, either it would be kind of impossible or I'd have to add a whole bunch of extra checks. With one line, I'm saying everything. And I can be declarative rather than imperative about it. The impact on the second verification method, verifying the main page, is far greater, right? Remember how we had several lines of those assertions? Again, I can replace it with a one-line snapshot call. Snapshot that whole windows, eyes check. One line replaced several lines. And so that's really the third major advantage visual testing has over traditional functional testing. Visual snapshots greatly simplify your assertions. Instead of spending hours deciding what to check, figuring out locators, writing all that transformation logic, you can make one concise snapshot call and be done. As an engineer myself, having spent a decade working on test automation projects as a software engineer and test, I cannot understate the cognitive load this removes from the automation coding process. Being able to just say, eyes check versus, oh gosh. I said it before, and I'll say it again. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. So now, what about cross-browser and cross-device testing? It's great if my app works on my machine, but it also needs to work on everyone else's machine, right? The major browsers these days are Chrome, Edge, Firefox, and Safari. Chrome seems to have market share. Edge is rising. Firefox, sadly, very small footprint. Man, when I was in college, like Firefox was the thing. It was like, 30%, 40% market shares, really rivaling IE. Chrome came out and just ate its lunch. Anyway, thankfully, we shouldn't have to do IE 11 anymore. Microsoft has killed that project. Some folks may still have to do some testing on Internet Explorer, but hopefully less and less and less now. That's browsers, but also there's mobile platforms. We have iOS and Android. So I line these up and you might think, hey, that doesn't sound like too much hassle, but let's consider. Not only do we have these browser types and these platforms or these mobile iOSs, or mobile operating systems, excuse me, but we also have versions for the different browsers. Typically, you want to verify that your app works on the latest version as well as the past 1 or 2 or 3 releases. Now, these days, it seems like every browser gets an update on like a monthly basis. So it's like a constant game of trying to keep your versions up to date and go back a few for the people who haven't quite updated. Like funny story, like my wife on her phone, she's adamant about like not doing updates. She doesn't like things changing. So I was like, oh my gosh. So we want to make sure we're back level for folks like that. So browser type, browser version. Also screen size. Ooh. Modern web apps have responsive designs. It looks differently whether you're like this, or this. Excuse me. So the way the application is rendered will change based on the viewport size. So that's a whole layer of complexity. And then specifically for mobile, you also have all the different device types. Just because we have iOS and Android doesn't mean it stops there. We've got, I don't know how many different kinds of iPhones, how many different kinds of Samsung Galaxies and Google Pixels. I can't even keep up with it anymore. Like, if you ask me, what's the latest model? I don't even know. I'm stuck on an iPhone 7, y'all. Like, this is my life. It's iPhone 7 for the win. Yay. Keeping it classy, keeping it old school. But this just adds a combinatorial explosion to our cross-platform testing, because you start doing this cross product by this cross product by this cross product, and you're easily into the thousands, millions of different combinations that you could test. And what's really frustrating is with more traditional kinds of automated tests, we'd have to run them start to finish in their entirety on each of those platforms or each of those configurations that we'd specify. Most teams will pick the first few combos and then skip testing the rest. And even with only a few combos, that can still require a lot of execution. So this is another way where visual testing can come in and simplify this. We already know that visual testing captures snapshots of your page, of your application, and looks for differences over time. But I was very careful in that word snapshot and not screenshot. A screenshot is merely a rasterized capture of pixels representing an instantaneous view. It's frozen in time and size. But a snapshot captures everything on the page that makes it what it is. HTML, CSS, JavaScript, everything that would be needed to render that page. Snapshots are way more powerful than screenshots because snapshots can be re-rendered. For example, I could run my test one time on my local machine and use Google Chrome, and I could capture that login page and that main page. But then what I could do is I could take those two snapshots of my two pages and then re-render them on other browsers like Firefox, Safari, and Edge. I wouldn't need to run my test from start to finish 3 more times. All I need to do is re-render the snapshots in the new browsers and run the Visual AI checker. And I could re-render them also using different versions, different screen sizes, different mobile devices, because I have the full page and not just a flat screenshot. And this works for web apps as well as mobile. And what's really nice is that this type of visually based cross-browser testing is lightning fast compared to more traditional methods. A typical UI test case will take about a minute to run, industry average, rule of ones. It could be more or less. 1 is usually what I've seen. But a visual checkpoint backed by Visual AI will really only take a few seconds to complete. Boom. So do the math. If you have a large test suite with, let's say, like hundreds, even thousands of tests that you need to test across multiple platforms, then visual testing could save you hours, if not days, of execution time for every time you want to run those tests. With Applitools, we have a service called the Ultrafast Test Cloud, where we have Ultrafast Grid and native mobile grid, where you don't have to set up those configurations yourself. You would just kind of specify, hey, I want, mobile Chrome on an Android, or I want Safari's back version -2. So you can spend, less time and money for your full testing efforts. So this is a big, big deal with cross-browser testing. Visual snapshots enable this lightning fast CBT. So I know I've made a lot of big claims in my talk so far today. So let's actually see this in action. What does it look like to do visual testing? I have an example project here. It's on my GitHub, Automation Panda /Visual Testing Revolution. You can get the QR code here. You can go to this link. We can share it out in chat in a little bit. But everything I'm showing today, fully available for you to try. So with that, I'm going to flip into the code. Boom, boom. And let me increase the size here. Oops, wrong way. So here in this project, this is that repository I just mentioned. I have a traditional test class that shows how to run that login test with the traditional ways. Boom, boom, everything lickety split. And then I also have the visual test class where I'm using Applitools visual testing. And here you can see like the verification methods are much, much shorter than they were before. So if I want to run this, I can run the test. And so I'm going to run it against the original version of our demo app site here. And we're going to run it. And so it's running. We should, yep. So, whoa, flip to the other screen, sorry. This is the test running in Google Chrome. I have it in headed mode so we can see it go. Hands off the screen. We saw the test ran. So now what it's doing is it's uploading the snapshots it captured to the Applitools cloud. I'm going to switch over. Here is my Applitools dashboard. And so if I refresh, you can see, here's the batch of Visual Testing Revolution. And right now, the test has completed locally. What it's running are those snapshot renderings. And we have it configured to run here against 5 different browser configurations. We have it running against Chrome on a desktop with a viewport of 800 by 600. We also have it on Firefox, on IE11, on Edge, on Safari, you know, these kinds of things here. And so, oh, wow, we have even more. There weren't just 5, there were 10. I forgot. And so let's refresh that real quick here. So here we go. Not only do we have that, but we have some mobile platforms like Pixel 2, Galaxy S, Nexus. And what we did is, if I open up one of these, here we see those 2 snapshots, and they've been rendered. Since this is the first time the test is run, it is setting this as a baseline. Hence, you'll see the status message for new. And it took only 54 seconds to run these 10 different variations. So that's two snapshots, 10 configurations, so essentially 20 visual tests in less than a minute. Rule of ones, 20 tests for the traditional sense would take, what, 20 minutes? I mean, I guess if you're doing like one configuration instead of the 2, it would be 10 tests, so 10 minutes, but still order of magnitude. So let's run this again real quick and see what happens when we run it with checkpoints now. So again, I'll run it against the original page. Also note, I'm running this locally just because I wanted to walk through the code and show you that. You could also run this from CI, right? You can make a GitHub action and run it from there. You could integrate it to like Circle CI or Jenkins or whatever platform you use. In fact, the example repository that I showed has an example GitHub action that you could use to kick it off anytime you push a change or open a pull request. So that could be really nice. All you have to do is put your API key in as a secret to your repo. So bouncing back here, we should see there it is, the second batch. And so it's cranking through. Right now it's still running. We can see that some of them have now passed. So if I were to open up one of these now, we can see on the left, we have the initial baseline image. That's like the good starting point. On the right, we have the checkpoint image, which would be like the next run. And so here, the test is passed because no visual differences were detected between these. And that's great. So now if I refresh them all, yep, they're all done now. And so everything, instead of being new now, is passed. Applitools will automatically see, aha, I don't need to explicitly mark it as passed, it can tell. Also note that, yes, because we have those different configurations, they would yield different, rendered snapshots. That's why we have to have them all as different results, right? Because otherwise, we're comparing, let me see if I can get a good example here. Like, the 800 by 600 viewport is going to be a lot different from the 1600 by 1200. You can kind of visually see that. So we want to make sure we're always doing apples to apples here. You can even see in the smaller rendering how the responsive design was different than on the bigger screen. So it can capture things like that automatically. It's pretty cool stuff. One more test I want to run with y'all is to run it against that broken page with a visual bug. Remember the one with the icon broken and stuff. So I have that set up as a run configuration already here in IntelliJ IDEA. If you're familiar with this, all it does is it calls the Maven test command, and it actually have my API key stored as a secret there. So I'm not going to show you the run config because I don't want to reveal my API key to y'all. But you could also do this from command line, whatever is most comfortable. So if we run the change test, here we go. Oops. So here's the test running locally, and it'll come up in a split second. Hopefully there's enough time to see how that, yep, the broken page is loaded. Boom, boom, great. Flip back to the Applitools dashboard, and already we see the batch up there. It's pretty quick. Boom, boom. So it's going to run these. And what should happen now is it should identify the visual difference. So we'll give it a moment. Come on, man. There we go. Ooh, here we go. It's already coming in. So if we look at one of these here, you can see that the status is not necessarily failed. It says unresolved. And it's orange instead of red, and it's unresolved instead of failed because this is the first time it's detected this kind of visual difference. What we have to do as the humans here now, developer, tester, overseer, whatever you want to call us, is we need to come in and see, hey, there was a change detected. We decide if it's good or bad. So I'm going to open this up here. And what can we see? Kind of like we saw before. Hey, it identified those visual differences, the icon, the sign in button, and remember me. And it's highlighted in that pink magenta shading so that it catches our eye automatically. Also, a trick we can do is there's this setting here called hide diffs caused by element displacement. Like sometimes elements are the same, they're just shifted a little bit. And so if we select this, that remember me checkbox, it's still the same element, it just shifted because of the login button. So we can kind of filter out that visual difference. We could also do other kinds of filters like ignoring the text and just looking at layout, those kinds of things, just kind of refine. Or instead of taking the whole page, we could take a region of the page as a snapshot, really fine tuning what our assertions are. But either way, for this, as we said before, this is fail. So what we want to do is I want to say thumbs down. This is a failure. It'll be marked as a failure. And also a really cool thing is Applitools will look at other similar visual snapshots and see if there are any other tests that should automatically be marked as fail. And so you can see here, even though I only clicked one failure, 1, 2, 3, 4, 5, 6 tests were eventually marked as failure. So that leaves me less churn and burn trying to go through these. So I can also mark it thumbs down from here. This one also failed. This one's failed. So there's a little bit of tedium at first trying to fine tune these things. Also, we should note that the second screenshot here of the main page didn't change. And so that one was passed everywhere. So pass or fail is really at the snapshot level, and it rolls up to the test level here. So anytime we mark test as fails, we need to make sure we save it. And another really cool thing here is that Applitools will remember those as failing snapshots. So if I were to rerun the test again with the changed page, it would see, oh, that was the failing snapshot and automatically mark them as failed. I don't need to explicitly manually mark them. And if I were to run the original page again, Applitools would recognize this back to the passing state and it would mark everything as passed. So that's really, really cool. And that's visual testing with cross-browser testing in a nutshell. I've shown how to do this with a web app. You can also do it with mobile. So before we get to Q&A, there is one more point that I would like to make. And I mentioned this before, but I want to hammer this again. I want y'all to think about like when should a team adopt visual testing? I mean, I've shared visual testing with a lot of folks in a lot of places, and I've heard a lot of times people saying, you know, Andy, this visual testing seems really cool, but I don't know if my team is ready for it. You know, we're just starting. This seems new. I don't know if we can bring it in. What I would say to that is, absolutely, yes, you can bring it in. Visual testing is actually going to make your life a lot easier, especially when you start out. So consider this strategy. When you start out on a test project, start by automating a smoke test that navigates to different pages in your app and just capture snapshots of each one. The interaction is straightforward. You know, driver.get, click here to navigate, click here to navigate, just load all the pages. And your snapshots are one-liners. So very, very short, concise tests that would not be too difficult to develop. But even with that, it would still provide an immense amount of value for relatively little automation work, because you are capturing you're capturing baselines of all of your pages, and then you can focus your true testing effort on, you know, running those every time the app changes, and then looking for the visual differences. It's like 80-20 rule, 80% of the value for 20% of the work. And then later, when you get further into your testing journey, you have more time, more experience, all that stuff. You can then start to expand your automation project with larger tests, maybe refining some of your visual assertions, or using traditional assertions together with visual assertions, that kind of thing, to get really, really powerful tests. Test automation is hard, no matter what tool or language you use. Teams always struggle to automate tests in time and keep them running. I really think visual testing is a way to simplify your implementation and execution while catching more problems. It offers the advantage of making your functional testing easier. It's not a replacement for functional testing. It's something that supercharges it. And it's not something just for bleeding edge, superstar engineering kind of teams. It's here today. It's accessible for everyone. It's something that is now pretty much like an off-the-shelf kind of thing that you can add to your well-balanced testing strategy. And I do believe visual testing is a winning strategy. As we saw, several advantages over traditional assertions. You can use Applitools for this. Applitools has Visual AI to drill into like the good kinds of comparisons. We've got platforms like the Ultrafast Grid and the native mobile grid, where you can do that scale out cross-browser testing. You can sign up for free to give it a try. You can lift my example project if you want to do a test drive. So by the way, this would be the slide to take screenshots. I've got the 4 points or the 5 points here. I've got the link to the code as well as a blog article where it's basically like a glorified transcript of the talk that I've given today. So I'll wait for a moment for y'all. Capture a snapshot of that if you'd like. And so let's keep in touch. We'll take Q&A now. If you want to keep in touch with me, again, my name is Pandy Knight, Automation Panda. You've got my blog, my Twitter. Connect with me on LinkedIn. Also, I have a very adorable French Bulldog puppy. She has her own Instagram page. If you like French Bulldogs, if you like dogs, if you like happiness, follow her too. So with that, let's take questions with any of the time we have left.
Awesome. Well, this is pretty cool, Andrew. So I myself want to go ahead and try it today evening to see how it goes, with a couple of test cases. So we have a couple of questions in the group chat, so maybe we can take a look at those. And I have a couple of questions myself. So let's start from the group chat first. So I think Elena Isaac was asking, what is the name of the visual AI checker?
Great, cool. So if you're within like the Applitools products and stuff, there's a couple names for different things. So the AI backed technology for the comparisons that Applitools uses is called Visual AI. That's like the name of the technology. The name of the SDK, software development kit, that you would add to your coding projects, that's called the Applitools Eyes SDK. That dashboard I showed, where that's where you go in as the human and do your visual comparisons, that is called the Applitools Eyes dashboard. The reason I call it eyes is because it's supposed to be like human eyes. The cross-browser platform is called the Ultrafast Grid. And the equivalent of the Ultrafast Grid for mobile apps is the native mobile grid. So big product terms I know, but that's kind of how they all line up.
Gotcha. So one more question from Steven Chavez. So I noticed that you are using Selenium in Java. Can this be used in a different framework, in a different language as well? Oh,
absolutely. I should preface to say there are different visual testing tools out there. I am most familiar with Applitools because I work at Applitools. Within Applitools, we provide SDKs for all of the major automation tools and test frameworks. So I showed Selenium Java because that's still one of the most popular combos out there. Other popular things, if you're doing Cypress, we have SDK for that. If you're doing Playwright, Puppeteer, if you're in mobile and you're doing Appium or Espresso or XCUI or those kinds of things. We even have SDKs where it's like, if you just have a directory of screenshots or PDFs, we support that as well. Oh, it looks like Sanjay in the chat asked, does the Visual AI support .NET? Yes, we support .NET with Selenium.
One more question from GH. If the web page has dynamic data, then the test fails. How to ignore the dynamic data sections?
That's a great question.
Table grid data.
Yep, that's a bit more of an advanced topic, but I can address it here quickly. So that is that is a test data issue more than a visual testing issue. The bare bones basic simple answer would be, if you're using Applitools Visual AI, there is a match setting where you can make, it's called layout. You can make it focus on just the layout of the page, but ignore any of the specific text in there. So it's like if you've got, let's say, a table, a table or a grid, and it's got like garbage in, garbage out values, right? You can do a layout check, and it would only check, does your table appear? Do all the things spatially fit? Do the colors align? But whatever Englishy or Spanishy or whatever text you have in there is basically going to be ignored, so that it's not going to highlight in magenta or purple. So that would be like the bare bones basic. Let me just get the thing working. If you wanted a bigger conversation would be like, how should a test project handle test data? Woo, that's a whole nother talk right there. Because some things you could do is like, okay, well, do you want to make sure, do you want to like statically prepare your data so it's always consistent? Do you want to generate synthetic data that's true to production, but still like saved from PII and all that other stuff? If you want to learn more about managing test data, one moment here. I actually just gave a talk on this, managing the test data nightmare. So let me drop a link to that talk real quick, and I'll pop it in the chat here. So if you want to learn more about different strategies for managing your test data, give that talk a listen, see what you can learn from there. Basically, it's like there's a ton of different ways to handle it. Choose the strategy that works best for you.
Awesome. One more question, Andrew, from Damita. So visual testing is not completely new, isn't it? So SQL or OutIT were here before. So I want to add to this question. So I had a question related to this, because we used a similar thing in the past in our internal projects, so that we had to use SQL for taking the screenshot and then test it against it. But the problem was when the size of the screen changes, or like a resolution changes of the picture, we basically screwed up. Over there. So
yes,
all the testing is failing. So in Applitools, how this thing is handled? Probably you answered already, because you said snapshots better than the screenshot. So just if you could elaborate more on this.
Yeah. Oh no, absolutely. So yes, visual testing is not new. Like I mentioned before, we've been doing visual testing since computers had screens. We've been doing it manually. And even automated visual testing is not necessarily new. Like we could, like as a boot camp or college programming project, or like a hackathon coding challenge, we could probably sit here and actually implement an algorithm that performs a pixel to pixel comparison between two image files. That isn't terribly sophisticated. And so, yeah, there are plenty of visual testing tools out there, paid and open source and all that. It's not necessarily a new technique. But the value that I would say that Applitools brings to this is exactly what you said. The biggest frustration with visual testing historically has been that the pixel to pixel comparison sucks, right? It's like as soon as you have something change viewport size, or it's on a different system, the layout just kind of gets different, and therefore everything just gets invalidated. It just kabooms, right? That's where that visual AI piece comes in, right? That we're not doing a pixel to pixel comparison that is very brittle, but rather we're using AI to kind of figure out like, okay, there may be a few kinds of spatial changes on this page, but ultimately we're going to hone in on the pieces that are different. So there's that tolerance built into Applitools style of visual testing, so that it's much more robust. It's much more resilient. Like we saw with that find the difference in the underwater picture, right? You change the layout just a wee little bit, and boom, the whole thing blows up. But with visual AI, it can still narrow in even with slight tweaks and changes. So that's what makes what Applitools does special. And that's why it's like, there are many visual AI tools, or sorry, there are many visual testing tools out there, but look for the ones that, like Applitools, have that robustness built in, have that visual AI built in. And I think Applitools does it very well. I think they do it better than anybody else.
Awesome. Awesome. Well, this was a cool presentation, Andrew, and thank you so much for such a great presentation. For the audience, excuse us, guys. So we are like 6 minutes over our planned time because the topic was hot. And please check out Andrew's tech blog at automationpanda.com and follow him on Twitter as well at Automation Panda. Thank you again, Andrew, for your time and expertise, and on behalf of our Houston Software Quality Engineering Group and our presenter, I would like to thank everyone for joining us and wish you guys enjoy the rest of your day. Thank you. Thank you, Andrew. So we should probably schedule something again for different topics if you have. So I think it's going to be cool for our audience.
Sure. Well, thank you so much for inviting me. I'd love to come back anytime. Just